Hello students, I am back with a session of programming. So today we are going to write a program for calculating permutations and combinations of r things out of n things, where values of n and r are provided by the user. So what is the formula of permutations and combinations of r things out of n? So we can write permutations as NPR, that is permutations of r things out of n things, and the formula is n factorial divided by n minus r factorial. So this is the formula of permutations of r things out of n things, and the formula of combinations can be given as NCR, that is number of selections of r things out of n things can be given by n factorial divided by n minus r factorial divided by r factorial. So these are the formulas of NPR and NCR. Now here we want to do a bit of modular programming. So till now whatever programs that we have seen, we have never written any new function other than main method. Whatever was our logic, we used to write it in main function. But this time what we are going to do is we are going to write a modular program in which we would divide the logic into different methods, and we would call those methods from main method or the one method from the other. So that is our agenda. So here if you see in the formula we have this factorial operations coming time and again. So here we have n factorial and n minus r factorial, and for NCR's formula we have 3 factorials: n factorial, n minus r factorial, r factorial. So if you see this operation, this factorial operation is appearing time and again in these two formulas. So what we are going to do is, first of all we would write a function to calculate factorial of a number. So let us go ahead and write such a function. So so main function is an important function, that is entry point of any C program. Apart from that we can write other functions as well. So here we are going to write a function which would calculate, given a value, it would calculate the factorial of it, and it would return the value of the factorial of the number. So the factorial value would always be an integer, so the return value of the function would be int. Now let us name it as factorial, and we should take a parameter of which this function would calculate a factorial. Now so this is the value that would be passed into this function, and we need to calculate the factorial of this value n inside this function, and then calculated factorial value should be returned from this function. So what is the formula of n factorial? So n factorial is given by n exclamatory sign, that is n factorial, and the value is n into 1 into 2 into 3 into up to n. So this is the formula of n factorial. So for that what we are going to do is we are going to write a for loop, and would also declare a loop variable and another variable which would hold the value of partial multiplications, and we would initialize this value with 1. Now you would write a loop and which would run n times, because this is a multiplication series and there are n terms in the series. Therefore, we are going to write a loop which would start from 1 and it would keep incrementing the value of loop variable by 1 and it would run up to n times. So, I less than equals to n I plus plus, and now this value of I is basically giving us the terms of this multiplication series. So, in the first iteration value of I is 1, that is the first term of the series. The second iteration, as it has got incremented by 1, the value of I would become 2, that is the second term of the series, and so on and so forth. I would take up the values of the terms of the series. Now, we will have to multiply this value into this accumulation variable, and the accumulation statement would be like this: fact equals to fact into I. So, this is our accumulation statement that we have written. And now, how would this be able to calculate the factorial? So, this is it would calculate the factorial value, and this would be done by like this. So, initially the value of fact is 1 and at the first iteration the value of I is 1. So, 1 into 1, that is 1, gets stored in fact. Now, in the second iteration I becomes 2, fact has got a value 1, 1 into 2 is 2, that gets stored in fact. The third iteration I becomes 3, fact has got a value 2, 2 into 3, 6 gets stored in fact. In the fourth iteration I becomes 4 and fact has got current value as 6 into 4, 24. Likewise, so 24 gets stored in fact. Likewise, it would go up to n times and we would have n factorial getting accumulated in this fact variable. Now, after this loop, the fact variable would contain the value of n factorial and we would just return the fact variable's value out of this loop, out of this function. Now, so this is it. We are done with the factorial function. Now, the second thing is we would write another function for permutation and another for combination. Now, to calculate permutations we need two values, that is the value of n and the value of r. So, the function which would be calculating permutations of r objects out of n objects would have a return type int, because the permutation would always be an integer number, and we would give it a name as permutations. And because it has to calculate NPR, so it should take as a parameter the value of n and the value of r. The parameter names are not necessarily be n and r, it can be anything, but for readability purpose, as we are more familiar with NCR and NPR, we would name it as n and r. Now, here inside this we are going to calculate the value of permutations. So, let us declare a variable, and in that we are going to calculate using this formula we are going to calculate the permutations value. So, the value of permutations is given by this formula, n factorial divided by n minus r factorial. Now, we have already written this factorial function, and by using this we are going to calculate n factorial and also we are going to calculate n minus r factorial. So, it has to be written like this. So, for calculating factorial of n, we are going to call factorial function and we would pass the value of n. So, the value of n, we are getting it as a parameter in permutations, and that value we are going to pass it into factorial function, and this function is going to return as the value of n factorial. Now with the returned value we are going to divide n minus r factorial. So again we are going to, as this is factorial operation, again we are going to call the same function with now a value of n minus r. So how would this function call be executed? It would be executed like this. First of all, this parameter value, whatever expression we have given, that value would get calculated first. So n minus r's value would get calculated first, and whatever is the value, that would be passed as parameter to the factorial function, and the factorial function would return that n minus r factorial's value, which would then get divided by which would be used in this division. So n factorial n factorial's value would get divided by n minus r factorial's value. Now this variable, after this statement has got executed, this variable is going to hold the value of npr. That is what we are going to return to the caller. So we are going to return the value of permu to the caller. So we are done with permutations, and similarly we are going to write a function for combinations as well. Permutations, combinations. So as software engineers, we are much attached to copy paste, so that's why I have copy pasted the values of the function permutations again and have changed whatever needs to change. Now factorial n, combinations formula is factorial n divided by r factorial divided by factorial n minus r factorial. So this I am going to hold in bracket, and I am going to put into factorial r. Let us cross check the formula. N factorial divided by n minus r factorial divided by r factorial. So that is what we have done. Factorial n minus r into factorial r. So this is the denominator of the formula, and this is the numerator of the formula. Now all this functions prototype has to be put above the main function. So the function prototype is nothing but the first line of the function definition, and we can drop the function parameter names as well, just the return type, function name, and the parameter data types. This forms the functions prototype. So that needs to be put before the main function. This is a peculiarity of C compiler. Many modern compilers avoid this, are better in that sense that no need of such peculiar thing is required, like C# and Java. This doesn't require any declaration of prototype, function prototype before their use. Now in main function we are going to take the value of n and r from the user. So we are going to prompt the user first, enter value of and an R scanf %d %d int n int R ampersand n ampersand R. Now after taking the value of n and R from the user, now we are going to call this functions, permutations and combinations, and pass on the value of n and R to them. So first of all we would we'll call permutations, and we would hold its value in another variable p, and combinations value would be held in C. So p equals to permutations, and within that we are going to pass values of n and R. So when this statement would get executed, first of all the function call would be done. So value of n and R would be passed into permutations functions, and from this point, as you might be knowing, whenever a function call is made, the control then passes to the first line of the function. So permutation, when this permutations function call is made, the control would pass on to the first line of the permutations function. So it would come over here. Now this would get executed, this would get executed, and when the return statement is hit, then the control would return back to the place from where it got called. So it would return back to this place, and the next statement of this function call is this assignment. So whatever value is returned by permutations function would get assigned to the variable p. Similarly, when this statement would get hit, combinations, the control would pass to the combinations function, it would get executed, and then whenever this return statement would be hit, it would return back to the place where it got called from, and whatever value was returned by combinations function would get assigned to the local variable C. Now after calculating the value of permutations and combinations, we are going to print it to the console. The permutations and combinations of %d things out of %d things. We are going to replace this %d's with the value of R and N. R %d and %d, and these two %d's are going to get replaced by permutations and combinations value. So first two would get replaced by R and N, that is R things out of N things, and then the value of P and C that holds the value of permutations and combinations would replace the value of would replace third and fourth %d's. Permutations, lot of spelling mistakes. So at the end, though in code block there is it is not mandatory to write getch, but in other IDs you might require to write a getch to view the output on console. Now we are done with our coding, and this is modular coding. You know, all the logic is divided into several functions here, and this is what we call modular coding, way of coding, and this enhances readability and maintainability of a program. Maintainability means whenever there is a bug in the code, it would be easily resolved. Say for example this factorial function, As here for calculating permutations and combinations, this factorial function operator is appearing 5 times, n factorial, n minus r factorial, n factorial, n minus r factorial, r factorial. It is appearing 5 times. So had we not written a factorial function, the logic, this logic whatever we have written inside it has to have got repeated by 5 times. So if any bug in the logic could have appeared, then we needed to fix it in 5 different places, which is not good way of programming. Better way is to put the logic of factorial within a function and call it from 5 different places. And also if there is a bug found in factorial's logic, then we need to modify it in only one place. So that is the benefit of modular programming. One is readability, other is maintainability. Now let us build it and see the results. Hopefully the result would come out to be correct. It has got built successfully. Now the value of n and r, let's say 5 and 3. So the value, the permutations and combinations of 3 things out of 5 things are 60 and 10. Now 5 factorial divided by 2 factorial, 5 factorial divided by 2 factorial is nothing but 5 into 4 into 3, so that is 60. So it is correct. Now 5 CR is 5 factorial divided by 3 factorial divided by 2 factorial. So this is also correct. 60 divided by 60 divided by 3 factorial is nothing but 10. So this is coming out to be correct. So we are done with our program and it is working fine, and we have done a modular programming. So if you are new to it, get introduced to it, because in all industrial level programming we usually go for modular programming. Not all the logic is written in same function. Usually the logic is divided into different pieces of code, and each piece of code does a specific thing, and for that specific piece of code that specific piece of code is put into a function, and that's how industrial level programming is done. Thank you for watching. Bye.